Energy transfer revisited. In this short video, we'll talk about energy transfer. And throughout the video, I'll have 7 questions, and I'll be asking, in which direction does energy transfer? So you're going to be thinking, is it transferring from point A to B or point B to A? So on this first page, remember back to what happened when we mixed water. This was the colder water. This was the hotter water. So we had a hot particle. We could literally have billions of particles. And when we mix them together into the cup, and these two collide, these are just 2 particles of billions that collide when they're mixed in the cup. And we said, okay, we figured out in class by looking at our data that to figure out what the temperature of the mixture would be, we simply would find the average. So we said 40 plus 60 divided by 2. Well, 40 plus 60 is 100. Divided by 2 would be 50. 50 degrees Celsius is what the mix was. And all this takes place because the particles, when they collide, I'm showing them in black now, a different color. When they collide, energy is transferred from the warmer particle to the colder particle, which causes both particles to change a little bit. The colder gains a little heat energy or kinetic energy, and the hotter loses. So through write 1 through 7 and then answer the questions as I pose them. So number 1, I have a picture of Lambeau Field. This is pretty modern day. Guys sitting on Lambeau waiting for the game to start as the crowd starts coming. Metal bleachers. And this is the ice bowl. I think it was negative 13 degrees. And it looks like everybody's standing. I wonder if they were standing for a reason. But question number 1, which direction does the energy transfer? Does the energy transfer from A, the cold bleacher, to the warmer rump? B, from the warm rump to the cold bleacher? Or C, in both directions? Pause the video if you need to. Next question. If I have a piece of ice in my hand, which direction does the energy transfer? So I take a piece of ice and I put it in my hand. My hand starts to feel cold, and it's feeling cold for a reason. Body temperature is 98.6 degrees for humans. And even if I turn it to the side now, you'll start to see that water is dripping. In which direction is energy transferring? Is it transferring from my hand to the ice cube, or from the ice cube to my hand? Okay, in class we used these hand boilers, and the hand boiler is a piece of glass that's sealed. In this case they have a little decorative look, and there is a liquid, and as we held on to the glass, the liquid would rise. You can kind of see it rising. My hand's kind of cold, but if I hold it long enough, the liquid will displace to the top tube. Which direction does the energy transfer? Is it transferring A, from my hand to the gas in the hand boiler to the liquid? Or is it transferring from the gas and the liquid in the hand boiler to my hand? So hand to boiler or boiler to hand? Okay, in this picture you see a container of blue liquid put in an ice bath. So here's the blue liquid, here's the ice bath. I think I'll tell you the temperatures here. Put a thermometer in to get the temperature of the ice bath. Find out what the liquid is. So in the ice bath, it looks like 5 degrees Celsius, and looks like 20 degrees Celsius. I took this right out of the kind of the warmer tap. So 20 and 5. So if I take this and I put it into the ice bath, similar to like putting a can of pop into your cooler full of ice, which direction does the energy transfer? Does it transfer from the ice to the container of blue liquid, or does energy transfer from the container of blue liquid to the ice? What you see here is a piece of copper that's in a container full of water. And we're going to pretend that we left this piece of copper in this container overnight. Which direction does the energy transfer? Okay, so we have to think, they sat here overnight, and right now, this instant, which direction is energy transferring? Is it transferring from the copper to the water, or from the water to the copper? Or, I have the third choice, it's transferring in neither direction because they're both the same temperature. So one more time, is energy transferring from the copper to the water, water to the copper, or neither? They're both the same temperature, so because they sat there overnight, so no energy is transferred between the two. That was number 5. Okay, number 6. I have a cup full of hot cocoa here, and it's much too hot for me to put into my mouth or drink. So I'm going to put a small ice cube into my cocoa. So I'll drop it in. Which direction does the energy transfer? Does the energy transfer from the hot cocoa to the ice, or from the ice to the hot cocoa? Number 7. So what we have here is something similar to what we did in class. I'm going to mix some liquids together. So before I asked you, was energy being transferred from the blue to the ice bath, or from the ice bath to the blue? Well, now we're going to say, okay, this one's at 15 degrees Celsius now. This one's at 5. So 5 and 15. So if I take 1, 2, I'm going to take 2 out of here too. So 2 from the warmer, 2 from the colder. This should be about 10 milliliters. And we find the temperature. So I want you to answer, which direction does the energy transfer from the blue water to the ice bath, or does energy transfer from the ice bath to the blue water? So that's the first question. And the second question is, what is the temperature of the water? So what is the temp? I can't write because my hand's wet. So what's the temp? If we had 15 degrees Celsius, and we had 5 degrees Celsius, and it was about 5 milliliters each, what would the temperature be? Okay, so that brings us to the end of the video, and in review, I want you to be thinking about energy transfer, I want you to be thinking about particles, and hopefully from these demonstrations and after we talk about this video in class, you'll have a better understanding.